in one-way ANOVA, we used to make one decision. Whereas in this two-way ANOVA, we'll make two decisions, right? Decisions about two things. So two decisions are to be made for this particular case. And moreover, in this one-way ANOVA, all the entries, all the data values may differ in number. Whereas the data values here in two-way ANOVA they should be same in number. So let me tell you how to solve this two-way ANOVA through a question. An experiment was designed to study the performance of 4 different detergents. So we have 4 detergents A, B, C and D, and moreover we are to study about engines. So we have 5 engines here. So they are saying an experiment was designed to study the performance of 4 different detergents for cleaning fuel injectors. The following cleaners readings were obtained with the specially designed equipment for 20 tanks of gas distributed of 5 different models of engine. So we have 5 different engines. So at 5% level of significance, we are to test whether there are any differences in the detergents or the engines. So here you see we are to make 2 decisions, one for detergents and one for engines. So we are using this two-way ANOVA. And the process here is similar to that of one-way ANOVA, but the difference here is that we have 2 things. One is detergents and another thing is this engines. So let's solve this question. And if you look at the readings here, the readings are same. That means we have 5 entries in the first row, in the second also, in the third also, in the fourth also. So we have equal number of entries in each of these rows. Whereas in one-way ANOVA, these number of entries they may differ. So that is also one of the difference here that you can note. Okay, so let's look at the solution. For the solution, we'll again construct ANOVA table. So we will construct an ANOVA table, and the table would contain, let me write down, it will contain source, it will contain degree of freedom, then it will contain sum of square, then mean sum of square, and then F ratio. These headings would be the same as in the previous case. So here, what is the difference? The difference here is that in the source, we will write detergents, because that about detergents we have to make one decision. Then we'll write engines, because about engines we have to make a decision, and we'll write error here, and then we'll write total here. So you can see that in addition to detergents, error, total, we have engines also. So we have one more thing that is to be studied here. So now we are to fill up all these values according to different formula. So let's see how we can do that. So here, first of all, writing the degrees of freedom. This is your degree of freedom. So writing degree of freedom, how many detergents are there with you? For degree of freedom, we will look for the answer, how many are there. So for detergents, how many detergents are there? They are in total 4, A, B, C and D. So we have 4 detergents. Therefore, its degree of freedom would be 4 minus 1. So we have 3. The degree of freedom here as 3. Similarly, for engines, how many engines do you have?
Ma'am, 5.
5. Therefore, our degree of freedom in this case is 5 minus 1. So that is 4. So we'll write 4 here. We do not know about error yet. We will calculate it by some other method. So we can talk about total. In total, how many elements are there? So how many entries, how many data values are there in total? 16,
And
20, right? 5 in each column and 4 in rows. So in total, we denote that by capital N, we have 20 elements. So the degree of freedom for total would be 20 minus 1. So that would be 19. So we'll write 19 here. Now in order to calculate for error, what we can do? We can either calculate it by total minus the degree of freedom for detergents. Detergents plus engines. So we have 19 minus 3 plus 4. So we have 19 minus 7, that is 12. So this is your degree of freedom for error. Or in this case, you can also do it like this: degree of freedom for detergents multiplied by the degree of freedom for engines. This is true in this case whenever you have two-way ANOVA. What is the degree of freedom for detergents? It is 4. For engines it is, for detergent it was 3. For engines it is 4. So we have 3 into 4. That is also equal to 12. So we have 3 into 4. That is also equal to 12. So by either method you can calculate this degree of freedom. So this is how we obtain our first column, the degrees of freedom. Next step is to calculate sum of squares. So next we'll calculate sum of squares. So sum of squares. So we'll again go for individual cases. For detergents, first of all, we have to calculate SS, and the formula for calculating this SS is summation Ti square divided by Ni No, actually this summation is over the term Ti square upon Ni. That means you'll write these terms for each of the components, and then you subtract C from here. Now what are all these terms? C is called as the correction term, as we have calculated in the last one-way ANOVA. And Ti is the sum total. Ni is the number of elements which are present in that particular row or column accordingly. So let's look at the table for detergents. So let's go back to our original table. For detergents, we'll calculate Ti. Now detergents, for a detergent we will calculate Ti. Ti would be obtained when you add up all these things. So 16 plus 8 plus 13 plus 2 plus 11. So this would come out to be 50. Then you will calculate this for B. For B it would be 16 plus 12 plus 18 plus 11 plus 18. That will come out to be 75. So that means you are adding this row wise, right? For the next you will have 14 plus 9 plus 12 plus 11 plus 14. So that will come out to be 60. And then finally you have 14 plus 11 plus 13 plus 8 plus 9. So that will come out to be 55. So this is Ti. And when you add up all these, 50 plus 75 plus 60 plus 55, so this thing will result in a number that is 240. When you add up all these, you will obtain 240, and this 240 is known as G, the grand total, right? And similarly, you will calculate the TIs for engines as well. For engines, we'll add all these quantities column wise. So it would be, for the first one, it would be 16 plus 16 plus 14 plus 14. So this will be 60. For the second one, it would be 8 plus 12 plus 9 plus 11. So it would be 40. And then here it would be 13 plus 18 plus 12 plus 13. So it would be 56. Here it would be 2 plus 11 plus 11 plus 8. So it would be 32. And for the final column, we have 11 plus 18 plus 14 plus 9. That is equal to 52. And when you add up 60 plus 40 plus 56 plus 32 plus 52, you will again get 240. So this number should be the same if you add up column wise or row wise, and this is known as G. So now we have TIs for detergents. These are for detergents, and these are for engines, right? This is for first engine, this is for second engine, for third, fourth and fifth. This is for A detergent, this is for B detergent, for C detergent and D detergent, and this is the grand total, right? So now we will use all these values, right? And what are the number of elements? This is your TA, and the number TNA. There are how many elements? 1, 2, 3, 4, 5. So in total we have 5 elements here. Similarly, for each here we have 5 elements, and here for each of these we have how many elements? 4 elements. So for first engine we have 4 detergents, for second engine we have 4 detergents, and so on. So accordingly, we can now obtain our sum of squares. Our sum of squares is obtained by calculating all this. So first of all, let us calculate this C. If you anybody remembers what is this formula of C?
Ma'am, G square by N.
Yes, G square by N. And we have calculated the value of G to be 240. So 240 square divided by capital N. Capital N is the total number of elements, that is 20 here. So we have this as 2880. So this is our C value. Now according to C value, let us calculate this thing for detergents. SS for detergent. So it would be summation Ti square divided by Ni minus C. So Ti, here we will have it for Ta by Na plus Tb upon Nb plus Tc upon Nc plus Td upon Nd minus C, because we have in total 4 detergents. So accordingly, if you look at the table, also we have square roots here according to formula, right? Okay, so now we wanted to have these values. So let's go and look back to our table. We have 50 for the value of Ta. This is for Na. Now this is for Tb and this is Nb. Similarly, this is for Tc and this is Nc. This is for Td and this is Nd. So accordingly, we have 50 square by 5 plus 75 square by 5. We have 50 square divided by 5 plus 75 square divided by 5 plus 60 square divided by 5 plus 55 square divided by 5 minus 2880. So when you solve this is the value of C that we have just calculated. So when you solve this out, this comes out to be 70. So we got our SS for detergents. Let's fill it in the table. So it is 70. Next, we'll calculate the same for engines. SS for engines. So again, we'll use the same formula, summation Ti square divided by Ni minus C. So this thing is equal to T1 square by N1, because we are calculating it for the first engine, then for the second engine, then for the third engine, then for the fourth engine, then for the fifth engine. minus C. Now we have all these values. Let's go back and look. For engines, this 60 represents your T1, and this is T2, this is T3, this is T4, this is T5, and the number here, they are 1, 2, 3, 4. So N1 would be 4, N2 would be 4, N3 would be 4, and N4 would also be equal to 4. So we have 60 square divided by 4 plus 40 square divided by 4 plus 56 square divided by 4 plus 32 square divided by 4 plus 52 square divided by 4 minus 2880, the value of C, and this come out to be 136. So we'll substitute this value over here. So this is your 136. Now we will calculate again for total. This we do not know how to calculate. So we'll calculate SS for total. So here, what is the formula? Formula is summation xij square minus C. Now small xij means it is for every single data value that you have. Now what are your data values? The data values, they are 16, 8, 13, 2, 11, 16, 12, 18, 11, 18. So for every of these digits, you have these values. So let's write down this over here. So we have the first value as 16 square plus 8 square plus 13 square plus 2 square plus 11 square plus 16 square plus 12 square plus 18 square plus 11 square plus 18 square plus 14 square plus 9 square plus 12 square plus 11 square plus 14 square plus 14 square plus 11 square plus 13 square plus 8 square plus 9 square. So these are all these values minus the value of C, and C's value is 2880. So when you solve this, obviously you will use calculator for solving this. So when you solve this value, it comes out to be 272. So we'll write this value into our table. So it's 272. Now for error, how can we calculate for error? It is simple. SS for error, it would be SS for total minus SS for detergents minus SS for engines, right? So for total, we just obtained 272. For detergents, from the table you can have a look. For detergents we have 70, and for engines we have 136. So when you add up, so suppose this is X, so when you add up 70 plus 136 plus X, it should be equal to 272. So we'll calculate this X. So 272 minus 70 minus 136. So it comes out to be 66. So we'll write in place of SS for errors the value 66. So this is our 66. Okay. Once you have this sum of square, next you will calculate mean sum of square. Now this is calculated when you divide the corresponding sum of square by the error sum of square. So it would be 70 divided by this mean sum of square is calculated. Let me write here the formula. Mean sum of square, this is calculated for each term when you divide the SS by the corresponding degree of freedom. So this is the formula. So when you divide 70 by 3, you have this mean sum of square to be 23.3. Now for this term, when you divide 136 by 4, the degree of freedom, that is equal to 34. And for error, when you divide the 66 by this 12, you have this to be 5.5. So here we do not require this thing, and here we will also not calculate this thing. So this is the mean sum of square. For F ratio, what you will do, you will divide this quantity 23.3 by the error value. Now the error value is 5.5. So this is your error value, error MSS. So this comes out to be 4.241 for detergents. This is the value for detergents. For engines, it would be, when you divide this 34 by the mean sum of squares of error, that is 5.5. So you have error of MSS. So this value is equal to 6.181. When you divide this, you will obtain this. So now this is our calculated value. So this is your F calculated. This is also F calculated. And we'll compare this value with F tabulated, and the value of F tabulated would be obtained for 3 degrees of freedom for detergent. So we'll write 3 here, and 12 degrees of freedom for error. And in this case, we will calculate this, we'll compare this calculated value with that of F 4 degrees of freedom for engine, because this value is for engines, right? So 4 here for engines, and then 12 for error. So we'll compare this one with this one, this value with this one, and this value with this one from the table, right? So let's have a look. This value would be given to you in the question itself. So here in this case, to make inference, what you have to do, you have to draw these two graphs, one for detergents, one for engines, right? So say this is for detergents and this is for engines. This is your middle value, and then we'll see what is our critical region in both the cases. So in the critical region, we will reject H0, and here in this case we'll reject H0. Here we will accept our H0, and because we are taking only the one-sided area, because in this case the value of F, that is always a positive quantity. We have calculated this F ratio 4.241 in case of detergents and 6.181 for engines. This is our calculated value. Now, in order to make our decision, we have to compare these two values with that of tabulated value. Now, what is the tabulated value? That is obtained, that would be given to you in the question, and that is obtained by looking at these quantities. So this 3 represents the degree of freedom for this detergents, and this 12 represents the degree of freedom for this error. And if in the lower case 6.181, here we will compare this with the value F 4,12. Now 4 is the degree of freedom for engines, because this value is for engines, and 12 is the degree of freedom for error, right? So we'll compare these two values. And moreover, in the very starting, you will define what is your null hypothesis. So here in this case, because we are making two decisions, so we will have two null hypotheses. One is for detergents and one is for engines. So for detergents, our null hypothesis says all the mean values for detergents are equal. So we will say mu A is equal to mu B is equal to mu C is equal to mu D. That means we will say there is no difference, there is no difference between the detergents. So this is your null hypothesis. What is your alternative hypothesis? There is some difference between the detergents. And similarly, we'll set up the null hypothesis for engines. We will say mu1 for that means mean for the first engine is equal to the mean for second engine, that is equal to mean for third engine, for fourth engine, and for fifth engine. All the means are equal. So we will say there is no difference between the engines, and H1 would be there is some difference between the engines. Now according to the values F calculated and F tabulated, will now make the decision, right? So here our comparisons would be made when you have the value F 3, 12 at 5% level of significance. So this value is equal to 3.49. This is given to you in the question, or you could refer to the table for this, right? This is for detergents, and similarly for engines. We are given this value, tabulated value, to be 3.26. This is given to you in the question, or you can obtain it from the table. Next we have F ratio. So let me write down here. What is this 3? 3 is the degree of freedom for detergent, and this 12 is the degree of freedom for error. Here 4 is the degree of freedom of engines, and this 12 is the degree of freedom of error, right? So we'll compare this value with that of the F ratio. The F ratio which we are calculated for detergents, that was equal to 4.241, and in this case for engines it was equal to 6.181. This we have calculated, this one also. Now according to this given value, we'll write down our region. So our critical region starts at the value 3.49 in this case. In the second case, it starts with 3.26. So now we will see our F ratio is 4.241. So 4.241 is obviously greater than this quantity, so it will lie somewhere here. So that means our F calculated value lies in our critical region. So we will reject our H naught. So in this case, we will reject H naught because our F ratio is greater than F3, comma 12, and in this case your value is 6.181. So 6.181 again lies here somewhere here, right? So this is also lying in the critical region. So here also we will reject our H naught. So finally we will conclude that therefore both the detergents and the engines are not all equal.